Okay, um, please have a seat, everyone who has not yet taken a seat. We are starting up the session right on time. We have 8 speakers of a high quality, so I'm eager to get started to not steal time from them. So honored guests, ladies and gentlemen, welcome to this technology session. We will go deeper into the current status for several of the key hydrogen technologies, like electrolyzers, fuel cells, and storage. Also, we're going to look into the application side in the shipping sector, where Norway has a thriving industry. My name is Daniel Rasvidal. I'm the CEO of Kjeller Innovation. We're a company that works mainly to commercialize R&D-based innovation from the research sector. But we are also establishing new technology-based startups, including actually quite a few focusing on sustainable energy and transport. Kjeller Innovation is also hosting and running the daily operations of the Norwegian Hydrogen Cluster through my colleague here, Bjørn Ottar Elseth, that you saw at the inauguration part of the conference. Let's see. Yes, and my own interest in hydrogen, should I say, started actually almost 20 years ago at university. That was the time where neither the core technologies that we going to go deeper into today, nor the market for clean hydrogen had reached the level of maturity that we see today. Even so, we have yet to see real mainstream adoption of green hydrogen in the economy. But the signs that this is quite imminent are many across industries and applications, like we have heard today. But we are not yet there, but we are getting there. And I think the session, which starts with an E, the end users, that is actually the key to scaling up. But to join these technologies with the end users through these quite long and complex value chains, that is a challenge that we together face. So, with that, we have 8 speakers that will shed light on these different themes and innovation going on in the industry from both India and Norway, and quite a lot of international speakers. We have a program which will be mixed in 2 sessions, so 2 times 4 speakers. Every speaker has 8 minutes. I will try to keep time and help you with that if you don't remember it yourself. And after a session with 4, we will have a short Q&A with these 4 previous speakers. And I urge you in the audience to please ask questions or come with short comments before we have a break for 20 minutes after the first 4 speakers. All right, so first of all, let me welcome someone who has actually been present all day. Our first speaker is Mr. Steffen Møller Holst, the Vice President of Marketing at Hydrogen Technologies at SINTEF, the Research Institute. And you don't really need a long introduction, but you have worked for a really long time, since 1990, with Hydrogen Technologies, and has depth competence basically with both the technology side, the societal side, and the political side of this. So please, today you will speak about innovative hydrogen technologies. Steffen, the floor is yours.
Thank you so much, Daniel. So, under this title, I would like to shed light to some of our engagements and projects. So let's get started. As you all know, passenger cars are not the only source for greenhouse gas emissions. In Norway, the heavy-duty vehicles are emitting almost as much CO2 as the passenger cars alone. And there is also, you would like to? Okay, no problem. We have also seen that from the Norwegian side that hydrogen will play a major role in shipping, and I'll come back to that segment of transport. We've since 2013 been engaged in trying to get a passenger train on the Norwegian tracks, and I'll come back to that topic as well, but let's start at the upper right with the heavy-duty trucks. ASKO is Norway's largest wholesaler of food, with large distribution centers, and some of them already have photovoltaics on the roof. And then this company has more than 800 heavy-duty trucks on Norwegian roads. Through a close dialogue with ASKO and their management, we succeeded in conveying the excellent properties of hydrogen as fuel for long-haul transport. And with that understanding, ASCO went to Scania and said, we would like hydrogen trucks. Scania was, in the beginning, very reluctant. They didn't have a plan to produce hydrogen trucks. But over lunch, they came back and said, we would like to produce trucks for you, hydrogen. And I think in between there was some mentioning that if Scania doesn't produce them, we will talk to Volvo. So 2 years later, we had the 4 first heavy-duty trucks, as you can see here, put on the road for tests in Trondheim. Battery electric propulsion is an excellent solution for shorter routes, but the longer the bus needs to travel, the heavier the batteries. And therefore, fuel cell range extenders has shown to be a viable and innovative solution. And in the Giant Leap project, we have developed, together with Bosch and the Dutch bus manufacturer VDL, an advanced control algorithm, which is indeed prolonging the lifetime of the system itself. And we have developed diagnostics tools which are enabling us to determine the system health, state of health, and the degradation within a few seconds. We're all aware of the many different charging systems that have hampered the market deployment of battery electric vehicles. To speed up the deployment of fuel cell electric vehicles, SINTEF took the initiative, and we are now coordinating the STASH project, in which we are standardizing the fuel cell modules for heavy-duty applications. We succeeded in gathering an impressive number of fuel cell manufacturers, 11 in total, and as well as vehicle and vessel suppliers. And the project has kick-started and will kickstart the market for fuel cell-powered heavy-duty trucks in Europe. And I'm confident that this will also benefit India's development, because the more standardized solutions we will get, the faster the market can develop. As new players come into the fuel cell and hydrogen market, the need to efficiently adapt the technologies to new drivetrains is increasing. In the virtual FCS project, we develop and share fully open mathematical modeling tools with the potential to be adopted as a global standard for fuel cell system design. To illustrate the use of this innovative software, let's take a look at the tourist ferry operating in the inner part of Sognefjord, better known as the Geirangerfjord, which is on UNESCO's list of World Heritage Sites. Norwegian Parliament has agreed to abandon any greenhouse gas emitting ship already by 2026. And given these restrictions, we've assessed how an optimal hybrid driveline should be designed and in the next step also optimally operated over the duration and the lifetime of a vessel, which can be up to 30 years. And in this respect, it's of high importance to also take into account the degradation of the technology and the poor performance over time. Over the last years, SINTEF has worked closely with Technip FMC, developing the Deep Purple concept. The subsea storage system facilitates large-scale offshore wind-based hydrogen production. It is suitable for It is suitable for near-shore storage, energy storage, and last but not least, it may provide for emission-free autonomous energy supply in remote areas. Last but not least, SINTEF has, as I mentioned, been engaged in techno-economic assessment of zero-emission rail operations. We're currently collaborating with 2 US universities on refining and improving models. And this spring we were engaged to find the best alternative fuel to diesel for a mining company in the northern Norway. The pre-study will be conducted in half a year's time, and I can already share the preliminary results showing that a hybrid system looks like to be the best solution for this train here. So let me summarize. SINTEF has taken an interdisciplinary approach in our projects, not only looking at the technology, but the economics as well as the societal aspects. We are doing a lot of life cycle assessments, and sustainability issues are core in our activities. We have developed advanced models taking into account, as I mentioned, the degradation of technology, the performance of technology over time, which is needed when you have a technology and a driveline that should last for 10 or 20 or 30 years. We have a track record of more than 20 projects where we support companies in their decision making, how they should preferably go forward when it comes to implementation of zero emission technologies. And we have been then through this activity, we've already seen the value of the feedback from deploying technology under realistic conditions, because then we can have an excellent starting point to develop next generation technologies. So by that, I'll thank you for the attention.
Steffen, good overview of all the impressive stuff you're doing over at SINTEF with partners. Our next speaker comes from a company called UMO Advanced Composites, and they work with storage solutions, and that is also what he will speak of. As you know, the unique flexibility of hydrogen comes down to the fact that it can actually be easily moved. But it's very important to make this safe, cost-efficient, and practical for customers and the whole distribution system. So please welcome Mr. Ole Enge Hagen. He's the Sales and Marketing Director of UMO Advanced Composites. So the floor is yours, Ole.
Thank you. I almost entered too early. But okay. Yes, dear ladies and gentlemen, I will talk a bit about storage and distribution models, because when you have produced, okay, it's live, yeah. So when you have produced the hydrogen from the electrolyzers, you need to bring it out to the fueling stations or whatever application you want to serve. So we are in that business. Short about our company, rather young, but now in the recent last years we have grown quite significant. Based south in Norway, focus only on large tanks in the start. So fit for purpose is the applications on the right side. It's for distribution of hydrogen or storage. It could be temporary or static. But also fuel tanks more for coastal ships and cargo trains. So not aiming at cars or buses in the start. That should be later on from our side. What differs us from a lot of other companies is that we are focused on using glass fiber in this kind of pressure vessels. That makes us very competitive. And also when we focus on the large tanks, you also reduce the number of potential leak points. So safety-wise, it's a really good thing to do. So just to show you, and since the theme is scaling up, down to the right on this slide, you just see how the orders has grown the last years. The base for the customers is Western Europe, mostly today, but we are also increasingly present, okay, so New Zealand, Australia, definitely also to US, not in 21, but in 20, and Korea and China. But talking about then a bit about the technology, this is just a cut-through picture. The grayish area is the plastic inner liner. It's a high-density polyethylene. Around that, we wind then high-strength fiberglass together with the epoxy. And as we are Indian visitors here today, it's also a pleasure to say that one of our suppliers is an Indian glass fiber production company called 3B, situated in Norway at Birkeland. So it's both close by, but owned by Indian owners. So all the parts we are using else is then composite and also then 316L steel. So when we have manufactured this pressure vessel, we bundle them into plug-and-play ready containers according to the need for the customer and their application. So it means highly tailor-made, I would say. Today, when looking at, let's say, the maritime application, we try actually to go in front and to standardize the solutions, because it will come more and more swappable containers, both as fuel tanks but also as cargo. I'll come back to that. So one of the customers I want to show is Hydrospider in Switzerland. You may know the project. They have an ambition to utilize 1,600 of the fuel cell electric trucks within 2025. Now I would say 2026, as they are a bit delayed. But status now of today is that they have 50 of them running in Switzerland. They are fueling about 8 tons every week continuously. And we are delivering all the units they are utilizing to bring the hydrogen from the electrolyzers out to the fueling stations. So down to the right, you see how it's on the outside. The small picture above is how it looks inside. So quite large vessels. So here it's connected to the electrolyzer, and then it comes truck to bring them out to the fueling station. Yes, Stefan, you already mentioned Deep Purple, so I don't have to say too much about the project itself. Our focus is to develop the subsea storage tanks. So down the yellow part in the sea bottom. That's quite a huge one. It's intended to be about 12 to 15 meters long, 2.4 meters in diameter. So each of them to store 1 ton of hydrogen. So we are on this mission, for sure not finished, but it will be scaled up. Also, we are looking a lot into the maritime sector, and this is one of the first bulk ship that will be, or maybe the first one, that will be sailing in late 24, I guess. They will aim to use containers as base for the fuel. So they will swap when they are at the quayside. So remove the empty ones down to the quayside, bring up full ones, and then sail on. Reduce the bunkering time, and also having a very flexible system. So scaling up, what are we doing? Okay, we are increasing because we need to increase when we see this market is running fast, even though it's I would say the early movers that's come so far, but it tends to be more and more projects coming on stream. So we will increase our capacity 4 times during the end of this year, start next year. But that's not the only measure we are taking. We have also made contracts for a joint venture in China, where we actually are going to build 3 times larger than the one in Norway. That the construction work has begun already. This is mainly to serve the domestic market in China, but we also see there could be export possibilities. In India, definitely we are following tracks to see if there are possibilities in India, and talking with some actors per now. Okay, thank you.
Thank you, Ole, and thank you both for being so timely. I don't need to raise my hand to tell you it's 1 minute left, because you're doing that perfectly yourselves. Our next speaker is coming from a startup company called Hystar. Jan Schmidt, who's standing beside me here, is the technical expert from Hystar. They're a company from Oslo, but a spin-off from SINTEF Research. They have a mission to develop PEM electrolyzer technology for a greener future. As part of Hystar's product development team, he is working on a highly efficient modular electrolyzer solutions. And today he will introduce us to Hystar, the company, and they are having a bold claim that they are making the world's most efficient PEM electrolyzer. So we're looking forward to hearing from you, John. The floor is yours.
So thank you. Yeah, let me maybe start with saying that Hyster is really grateful that we were invited and that we have the opportunity to present our technology here at the summit. And yeah, I'm really happy to take this job. The world's most efficient PEM electrolyzer. This is quite a strong statement, and I will use the next few minutes to explain why this statement is not just some kind of massive over-exaggeration, but actually reflecting reality. And to do so, let me start with the basics. So Hyster is a company that is located in Oslo. And what we are doing is Hyster specializes in ultra-efficient PEM electrolyzers for production of green hydrogen from water electrolysis. So what this basically means is Hyster is building and designing and manufacturing the PEM electrolyzer stacks. We also build the system around those stacks. And the interface we have to our customers is the power supply and a water supply. And we provide the system, and the output of our system is the hydrogen production. So that on its own doesn't make it special, but we're doing it in a really special way. And the important question is now, why and where does our efficiency come from? And the answer to this question is somewhat simple, but therefore really beautiful. So within SINTEF, the founders of Hyster have been able to create a process, an operation process, and this process is now patented and owned by Hyster. And this process is allowing us to do something all the other electrolyzer companies are trying to do as well, and that is reducing the thickness of the membrane. And we can substantially reduce, based on this patented process, reduce the thickness of the membrane. And when you take the order of magnitude here, so we're talking about 10 times thinner than conventional electrolyzer membranes. And on top of that, it's also making the overall electrolyzer, the PEM electrolyzer, safer. So this is a really strong statement, but to not just leave it with this statement, I have also brought a polarization curve. So a polarization curve is used to describe the general performance of an electrolyzer. And what you can see here is basically on the vertical axis, the voltage. And the voltage is somehow directly related to the power input into the electrolyzer. And on the horizontal axis, you see the current density. And the current density is directly connected to the hydrogen production rate. So the more current flow you have through the electrolyzer, the more hydrogen you produce. So what you can see there is two curves. The black one, is taken from a reference, a state-of-the-art electrolyzer. It's an internationally operating company. And you can see the green one, that is the reference curve from Hyster. And what you see here is that the green curve is significantly reduced in comparison to the black curve. And to also give you an order of magnitude, what that means is if we take the production rate and keep it constant for both systems, then it means that with the Hyster PEM electrolyzer, you can reduce the power that is needed to almost 15% in comparison. Or what you could also do, you could take the production rate, the power input, the voltage level you're operating the electrolyzer on, constant, and then you could shift the operation point to an almost 200% increase in hydrogen production. And that is a massive advantage, quite powerful statement as well. And what we further do at Hyster is, we've heard it today, scaling up and entering the market is really important. So what we are planning is, we want to combine our technology with a clever product design. And the basis of this product design we have is modular. So we create a module, and this module can then either be used in smaller systems, like containerized applications, or in larger plants by just multiplying the module. The benefit of doing it like this is that we can highly standardize our product. And with a high level of standardization, the benefit of mass production is coming as well. And that is something we definitely want to utilize. And by combining this product strategy with the technology we have, we are convinced that we can offer our customers a really, really good solution. And to also show that we're not just talking, we're also doing. We're really proud that we're already working together with 3 really big industrial partners. 2 of them I'm allowed to announce. The third one is an international player, also investing into hydrogen, but unfortunately I'm not able to make the statement now and today, but it will be announced within this week or the next one. But Equinor and Gasco, the 2 ones I'm allowed to mention, are also magnificent partners, and with them we're implementing our first electrolyzer solution into the market. And we're also heavily supported by the Norwegian government. So if you have any further questions, if you're interested in the technology, or if you want to discuss it, my colleague Luke is standing in the back of the room, and we're here and really happy to answer your questions or connect with you, also if you're watching online. Thank you.
Thank you very much, Jan. Our next speaker comes from not from Greenstat, but from a wholly owned subsidiary of Greenstat called Greensight. And Greenstat is a consultancy within the renewable energy sector. And Kjetil Midthun is the CEO of the company. He also holds a PhD in business economics and has been working for more than 20 years within the energy sector. And the topic is a continuation from natural continuation from Hystar's speech. He's going to speak about electrolyzer technologies, both emerging ones and established ones. So, and I have good news for you, because you said your presentation was 15 minutes, and because we are ahead of time, I'll give you the 15 minutes.
Well, thank you. I think I will do an 8 now, since I've adjusted my presentation. But the number of speakers were increasing as the program grew, so that was I made some alterations. But thank you so much. The title is Electrolyzer Technologies Emerging and Established, but I will focus mainly on looking at different characteristics of electrolyzers, and with the perspective of electrolyzers being part of a value chain. And this also goes back to the presentations that we have had in terms of the storage systems, for instance, and playing into the whole logistics of the business plan or the value chain you're setting up. So the actual instance will influence what kind of characteristics of the electrolyzers that you should focus on. So what I will do in the presentation is that I will look at or discuss some important characteristics of electrolyzers. So what kind of dimensions can we compare them at? What kind of characteristics are important in different settings? And then if I stick to the 8 minutes, it's a very short time to say much about the different technologies, but I will give a snapshot on some of them and just a brief comment. And I have also a summary where I show a little bit of some of the evaluations that we have done in Greensight in terms of looking at the state of the art currently and ahead in time at the cost side and also at the technology development side. So looking at some of the important characteristics, the first one is really, the main point is the use case applicability. So what is your setup, or what is the situation where you are planning to invest or install an electrolyzer in? And this refers both to the power source. So are you connecting the electrolyzer to a grid where you have stable electricity supply, or are you connecting this to a new setup where you have wind and solar production, for instance, as the main inputs? And these kind of setups are very different in terms of the characteristics you need for your electrolyzer. So in the grid connected instance, you have a very stable power supply, and you will have a high capacity utilization. Whilst if you connect it to these non-dispatchable power sources, you rely on the weather conditions in terms of how high you can actually utilize your electrolyzer. So this will highly influence your choice of electrolyzer. And this goes into, as we get back to, both in terms of the operational profile, so how low you are able to run your electrolyzer, but also in terms of the flexibility and how fast you can ramp your system. The second one is on the production profile, or we can also say that it's in terms of the load or the demand side. So it depends whether or not you're installing this close to an industrial offtake that might be stable and where you have a firm offtake of your production, or if it's linked to a variable offtake and demand. So either this being linked to transportation purposes, or you have to set up your value chain in a way that you have a buffer in terms of storage tanks and so on, and you would want to vary the production on your electrolyzer. Or it might also be, as was presented by Stefan in the Refine case, where you utilize the electrolyzer for actually balancing the electricity consumption within the industrial plant, and you get extra value for having flexibility in the electrolyzer. And lastly, it's exemplified with onshore offshore, but this might also go generally in terms of area costs and area availability. So how much area do you have available for installing your electrolyzer? Then there are some obvious criteria to use as well, as we have seen before today as well. You have the efficiency, so how many kilowatt hours do you need in order to produce a kilogram of hydrogen, and at different levels of utilization of the electrolyzer. And you also need to look at the total system setup, also in terms of when you're discussing the efficiency of your electrolyzer. So for some of the electrolyzers, you would need to add compression in order to get to the desired pressure level. Others, you might need to purify the hydrogen that you have produced. And in some, this will influence the overall efficiency of your setup, so for the whole balance of plants. And then you also have issues regarding lifetime and durability. So both in terms of when you will have to reinvest or change equipment, and also in terms of degradation and efficiency losses in your electrolyzer that will influence the efficiency and how much electricity you have to use in order to get to a given production level. So the size and dimension is another area that's important to look at. So the current density combined then with views on what the land and area cost or availability is. We often do these techno-economic analysis where both the capex, so the investment cost of the electrolyzer, and the operational cost of the electrolyzers are important to consider. And in these, for the investment costs, then of course you have to look at the whole balance of plant around the electrolyzer. You have to look at the material costs. For some of these, you have precious metals that is included in the electrolyzers, as it drives the investment costs. You might have to operate on high temperature, high pressure, and you might have to reinvest at given intervals. And then on the operational side, you have maintenance costs that increase during the lifetime of the electrolyzer. You have degradation and leads to efficiency losses. And as mentioned, you might also need to add compression, purification, and so on that drives your operational costs. So as we will see towards the end, then these different levels will be important in the different technologies and drive cost at different levels. And of course, for the investment cost, it will also depend on your financing costs and of your required rate of return and so on. And lastly, on these points, on the characteristics and dimensions, you have the maturity level of the technology. So whether or not it's commercially available, whether or not it's ready for scaling, and whether or not it's tested sufficiently to be reliable and have a low risk of failure. And as we discussed, that we go moving from the megawatt scale to the gigawatt scale, and this will be really important in terms of how fast you're able to scale the different technologies. So I will go very quickly through the technologies. I put up the system diagram for each of them, and I'll be happy to discuss at a later point in time. So just very quickly, for the alkaline, you have the advantage of having a very mature technology with a relative low cost without the precious metals, making it easy to scale in that sense, but you also have low current density, leading to a large size of the equipment or the installations. You have some issues with gas crossover, and you need to add compression. And also, as one of the main differences towards the PEM electrolyzer, for instance, you have more issues in terms of the dynamic operation. So it's less suitable for environments where you rely on dynamics. If we then look at the pressurized alkaline, you have some improvements compared to the traditional alkaline with higher outlet pressure, giving you a quicker response time, so the possibility to use it in more dynamic environments. But you also have larger challenges in terms of the purification, and you have quite strong limitations on the minimum load, giving you challenges on your operating range. And as for the alkaline, you also have some issues with the space efficiency. For the PEM, you have high purity, you have high responsivity. Sorry. You have a large operating range. It's compact. It's, I think it was mentioned, ultra efficient for the high-star solution, or at least highly efficient. So you have a lot of these advantages. So then you have the challenges then in the precious metals and the leading to potentially higher costs and scalability issues. I'm stealing a little bit of the 8 minutes, I see, but I'll try to limit it. Then for the AEM, you have again advantages of the purity. It's a relatively compact system, relatively fast response, and it's a potential for low investment costs, depending on how it develops in terms of the precious metals. So in some sense, it combines some of the benefits from PEM and alkaline. So our main challenges in terms of it's rather immature still, so there are some questions still regarding durability, degradation, the lifetime, and as I mentioned, the need for precious metals, which are being worked on. So finally, I also included the solid oxide, which has the advantage of being highly efficient given the steam input. So if you have steam available in your industry that you link this to, you have a very efficient electrolyzer. You have relatively low material costs and high purity of the end product. So some of the challenges, you have a relatively large footprint, and you have issues with regards to lifetime degradation and also variable or dynamic operation given the dependence on the steam input. So that was a very, very quick technology overview of some chosen electrolyzers. So the main message is that the suitability, and when you're going to evaluate the electrolyzers, is really important what kind of use case you're looking at. What do you have available of input in terms of electricity, the quality of the electricity, and whether or not you have steam, and also the areas that you have available. This shows an example of the total long-term cost of hydrogen for different electrolyzers. So unfortunately, they are anonymized, but it gives the indication of how it varies between the different technologies depending on their characteristics. So you have different cost drivers for the different technologies, and depending on the use case and depending on the circumstances in where you're setting up the electrolyzers, you might have cost benefits within some of these areas that will influence your choice of electrolyzer technology. And you also have, as I mentioned, the footprint difference that should be taken into account when considering what kind of technology to use. Yeah, so lastly, there is continuous development and many interesting developments within the electrolyzer technologies that will hopefully and likely influence both the costs and the efficiency and usability and scalability of electrolyzers moving forward. Thank you.
Thank you very much, Kjetil, and please, just stay on the stage. I will also invite the previous speakers, so Stefan and Jan, please come up, and also Ole from Yuma. So I guess we'll have consultancies and R&D there, and companies over here. Companies over here. We'll have to have the whole triple helix thing here, even though we have no government representatives here. I thought it was a really interesting session because all of you talked about, to some degree, standardization as a key to scaling up and cutting costs. But could you perhaps elaborate, maybe first from the company side, how important is standardization, and are we on track within your different technology solutions? Maybe first you, Ole, from storage side.
Yeah, from the history, the large gas companies, they have actually, if you look at companies like Linde and Air Liquide, they actually have their own solution today. So it's not standardized from history. And that's where we start for some reason. But we have to find common ground, I would say, and I think in maritime, it's easier to do it because that's brand new. So today it's not that easy, because if I look on the onshore applications, look on the hydrogen customers we do have, it's almost one solution per customer.
Right.
So we need to get a standardized solution.
Right, thank you. And you, Jan, we talked earlier before during the lunch or before that, and you mentioned that some of the inspiration from what you are doing with your approach with modular system is actually from the auto industry. Could you elaborate on why did you choose that kind of angle?
Yeah. That is also directly connected to the technology we are using. Since we are using a membrane that is a lot thinner than conventional membranes, we can also utilize the production processes that are used for fuel cell production. So in fuel cell, you have a really high volume and low cost requirement, and we can piggyback a little bit with this development, and we can utilize the improvement that has been done for fuel cell for our electrolyzers. And that is a great benefit we can utilize, and that is also what we're planning to do. So standardization is a really, as you said, a really important thing for Hyster. So we're also planning to have a fully standardized and automized stack production in 2026 that is able to produce 1 gigawatt of electrolyzer. And yeah, it is a really, really important topic for us.
All right, thank you. And talking about the automotive industry, just hold on one. You mentioned, Stefan, that you are coordinating a consortia of 11 heavy-duty truck manufacturing companies, or bus or heavy-duty at least. Can you give us some reflections on how that is going within that certain segment? And is it like a requirement to actually land on one standard, or will we have a few different ones? Even I know the goal is probably one standard.
Yeah, I think it's important to. Is it working?
I think so.
Yeah. It's important to understand that standardization is not, you can see that in different levels. You can look at that when it comes to regulations and things like that. But in my talk, I talked about the STASH project, where we are standardizing the interfaces, meaning that we make sure that when you develop a driveline, there can be multiple suppliers and competing suppliers of the core technology, meaning that when you agreed on the interface, maybe half or potentially all the 11 fuel cell suppliers can compete when it comes to delivery of fuel cells. So there are so many levels of standardization. Of course, in a plant like yours, modular technology, it's perfect for automation, right, or automated production in itself. Then you would like to make a standard which is then a module that is multiplied several times in your system as such. But in my presentation, I showed the need to standardize the interfaces, which is then facilitating the competitiveness between you and your competitor again, to then speed up the market deployment and lower the cost at the same time. So I think there are a lot of different levels and flavors of the word standardization in this case.
Yeah, thank you. That's a good academic answer. Kjetil, you're studying the markets basically for different technologies. And what do you think about standardization when it comes to electrolyzers? You mentioned all the different technologies here, but and the older ones like the alkaline are more mature, you mentioned, but can you elaborate on the different kind of levels of maturity and standardization of them?
Well, I have to think in terms of the standardization for the electrolyzers, how it plays in. But if I start with the market side, I think it's really important. We have discussed a lot about the chicken and the egg problem, and what the importance of co-develop the production side and the demand side. And I think additionally, when we look at markets such as the maritime industry and also for land transport, it's important to acknowledge that it's a network economics problem. So So the value of the first bunkering facility is much less than the value of the 10th bunkering facility, where you actually have a network available. And you can service a fleet of vessels with longer transport distances instead of just boats that use the same port. So achieving standardization in terms of bunkering systems and these value chain elements, I think, are going to be essential in order to build the market fast and to get higher volumes and also to be able to serve larger parts of the market.
And just to follow up on that, how important do you think, I mean, we heard in the plenary session the scheme that has been developed now in Norway with Enova, where they had this competition and they start building the infrastructure. How do you think that will, and you know, the same thing is happening all over Europe and probably globally. How is that influencing the different kind of, are we coming up with a million different concepts in every hub, or are we kind of working on more aligned technology concepts that are interoperable?
That will be interesting to see, I think, in the next 3 years. But I think at least that it's been given a lot of credit to Enova earlier today, and I think it's rightfully so, because I think they've done this in a very good way, and they're also stimulating both the production side and the demand side, and building these simultaneously. And I think it's the right way to go. And then we'll have to see how these different clusters develop. But I think it's very good that you have also this geographical spread, which is a very good starting point, I would say.
All right, and in the next session we'll have more of our Indian friends as speakers, and we'll also be addressing kind of the end user and market side of things even more. So look forward to that. Just before closing down this session, it's open for questions or comments from the audience. So if you heard anything here during the speeches or during the debate, please raise your hand and I'll take some questions. So first of all, you, sir. And please state your name and organization where you're from in the beginning.
I'm Dr. Mukul Das from Sri Ram Institute for Industrial Research, Delhi. My question is to you, please. And basically, what you have used is the glass fiber, especially for the scale-up conditions. I would like to ask that these scale-up conditions were for liquid hydrogen or for
Gaseous. Yep.
Gaseous. Okay. And yes, small questions are there. The next question is for you, please. Yeah, you mentioned that you have reduced the membrane thickness from 180 micron to 18. So in that scenario, you are comparing the similar composition of the membrane, or the membranes are two different types?
The membrane itself is staying pretty much the same, and also the components we're using and all the catalysts and so on. So all the materials of the membrane are similar, but the overall thickness of the membrane is significantly reduced. And by doing so, we are reducing the overall electrical resistance over this membrane. And by reducing this electrical resistance, you cut down one big efficiency loss within the system. And this is giving us this significant improvement.
Basic constituent of the membrane is the same. It's only the thickness what you have, and along with some of the catalysts you have modified.
That is also what I said earlier. The solution is really beautiful because it's so simple.
Yeah.
The patent is a really simple patent. So the background of it is we are ventilating the stack, and therefore we're getting the safety issue away, that hydrogen can diffuse over the membrane.
And how much is the efficiency of production of hydrogen?
So we are talking about the system efficiency now for efficient systems of 97%, so up to 80% efficiency.
Great, thank you. Just last, if you permit.
Please.
You have shown several technologies for hydrogen. Which is the best technology in terms of efficiency for production of hydrogen, of all the technologies what you have stated?
Well, it depends a little bit on your assumptions going into it. If you have hot steam available, then the solid oxide will be the most efficient electrolyzer, for instance.
Okay,
So,
thank you.
Okay.
All right, thank you. And let's see, we have many questions. I think the gentleman over there was first. No, the one behind you, and then you. Would you please step forward and just grab the microphone, state your name and your question if you want to come up, or speak loud. Yeah.
I'm Jayesh Gajjar from Air Energy. Basically, I have worked in fertilizer as well as now in refinery. Both large consumer of hydrogen. So, in terms of scale up, what we are seeing is in per day, say metric ton, 50 metric ton like that. Where for industry purpose it is in the multiple of 100. So, like say semiconductor or microprocessor chip development, by what time we can expect that scale up we can achieve for industrial use, we can say. Because many promises are there for vehicle use, for like everybody mentioned. So my question is to Stefan and for Jen, for electrolyzer plant.
Yeah. You want to answer from your side?
I can take it first, yes,
Yeah.
it's okay, if you agree. It is, for us, as I mentioned, so we are planning to ramp up our production line, the fully optimized production line, and have it ready by 2026, and then we want to produce a gigawatt a year of PEM electrolysis. So that is, for Hystar, the goal we want to achieve. We are currently adjusting it to even more, because the process or the manufacturing process we are thinking to implement is able to produce more. But this is a rough number, so 2026, about 1 gigawatt of hydrogen production.
Maybe I can add to this. The timeline and the ambitions are very ambitious in themselves. But what would be eventually the challenge here is that you need the entire value chain and the supply chain to be ready, meaning that you need your chillers, you need your power converters, you need every bit and piece in that puzzle, and that is, of course, could become a challenge, and we should make sure that we facilitate all those newcomers as well, because each of them needs to boost their production capacity.
But do we have any examples from already now large industries that have large-scale projects as the one that he is kind of asking for, that is actually now doing that, which is he's asking for from industry sides like steel or
There were so many bits and pieces, and as mentioned, the thing we need to be aware of is that hydrogen is a special gas, meaning that valves and whatever is needed in those power plants or processing plants will need to be, of course, compatible with the special characteristics of hydrogen, and in that respect, materials development is also the key here, not least to be able to handle hydrogen at a cost that is acceptable, because as you know, hydrogen penetrates metals, and you need to use pretty advanced alloys to make sure that you don't get metal embrittlement in those cases.
Actually, in industry cases, industry requires hydrogen in like a power grid manner. It's a continuous supply of hydrogen. So it's not a what you can say big challenge for what you can say storage or like that. Once hydrogen produced in a required quantity, then it will be consumed. So in that aspect, if many challenges for other practical purposes are storage, but not for process industry. Process industry is it's like a grid requirement.
Okay. Next question from gentleman over here, and then also Bimota.
Yeah, my name is Rajneesh, and I represent a cement company from India by name of JK Lakshmi Cement. Now, cement has two typical aspects. One is the manufacturing part, a lot of energy, and I think carbon dioxide, 6% of global carbon dioxide emissions are accounted for cement. So, a lot of energy required in manufacturing, and then it is very heavy duty transportation oriented. A lot of movement. So I have only two questions that, from the techno-commercial point of view, in order to replace the conventional fuels in manufacturing and using hydrogen in transportation, heavy duty transportation, what do you see the possibilities? When it becomes, technically viable and commercially viable?
Maybe a question for you for this side of.
Maybe I can start out.
See, even $1 a kg doesn't make it viable for the industry to replace conventional fuel with hydrogen. Unless until carbon tax comes into picture, that's a different thing. But if there is no carbon tax, even $1 a kg doesn't make it.
Yeah, you mentioned transportation, and I think the willingness to pay for hydrogen per kilogram is the highest in transportation, in fact. Whereas hydrogen used in industry is the willingness to pay and the competitive supply of energy is much cheaper in general. But I foresee that we would see heavy duty transport vehicles, vessels as well, a significant amount of these before 2030. And we need to do that because even though the Norwegian ambitions of cutting emissions from these heavy-duty transport and the maritime sector, we have ambition of cutting these emissions by half in 2030. So we are not able to do that by any means without hydrogen. We need hydrogen, and batteries in these segments will play a much less important role.
And how about cement industry substituting or using hydrogen, substituting other means?
Yeah, I think
raw materials. Yeah.
There are several projects looking into this, and from the utilization of the CO2 after you have captured it into methanization and so on in combination with hydrogen, and also to replace some of the energy consumption in the cement production itself, to technology advances in the production process itself. So there are various ways of looking at utilization of hydrogen into the cement industry that I think is interesting to pursue. And that's also that Heidelberg Cement is working on.
We have a pilot now in Norway which has been financed already. So capturing CO2 from cement production, so we could share more information about that.
Is that Heidelberg Cement? Yeah. Okay. Yeah. All right. Last question. Bjørn Ottar, Elseth from Norwegian Hydrogen Cluster.
Yes, Bjørn Elseth from the Norwegian Hydrogen Cluster. Very interesting discussion. Of course, very curious about technology development as a system engineer myself. So we have the first generation that has been going on for a long time. Second generation is coming up now. But the question is, are we going into another disruptive area? I'm thinking about, are we actually spending enough money in Europe now to compete with the world? Or are we organizing ourselves in the best manner, and which areas should we focus on? So many big questions here. This is with that H2 value chain in November 16, but maybe just a direct question. Will we experience much disruptiveness the next 10 years, according to your thinking now on this technology as we're ramping up the hydrogen economy?
Yeah, well, who wants to answer this one? Yeah, maybe you want to start, Kjetil first, and then, or Jan first. Yeah.
I personally think this is a really hard question to answer. I generally would say there cannot be enough incentives from the government, so I personally would love to see more, especially supporting those who are the early investors, because now a lot of people are waiting until the technology has matured, until they do the investment. So giving an incentive that early investors can benefit is something I would love to see from the government. So that is my comment.
So you mean both early investors and also early customers or end users?
That is what I meant with investor into the technology. So a customer that is able or that is willing to invest into the new technology and is willing to take this risk of going a step into something that is new should be supported by governmental incentives. And I think this should be heavily subsidized so that it can actually leap off if it pave the way.
Yeah, I agree, which is the boring answer, I guess. But but I think in addition to the continuous improvements that you see in the established technologies and some stepwise developments, there are some potential for disruptive new technologies, I think. But it's very hard to evaluate whether or not they will achieve the needed level of robustness, reliability, and so on. So before they get the necessary funding to actually test it at a proper scale, it's very hard to evaluate what the probability is of them succeeding.
I think just to add to that, Jan, that I think it's extremely important that we are not sitting more on the fence. We need to take into use what we have available now to learn from that and then iterate, provide the feedback and develop next generation. Because the longer we wait, the less possible it is to meet the challenge and the emission targets. So get those technologies which we already have at hand out there, and we will benefit both from the feedback and experience as well as the emission reductions they might provide, of course at a higher cost in the beginning, but that's where the contracts for difference needs to be established.
All right, thank you very much. An applause to the panel. Also thank you for the audience for engaging and asking questions. Please keep up the good work, both panelists and audience. We'll have a short break now, just a few minutes to catch maybe a coffee cup or something like that. I would suggest you go up that way so you don't interrupt the other session. And we'll be back in around 5 minutes, and you want to play a film in between, right? Okay, thank you everyone. We are starting up the second part of the technology session now, and thank you very much for the first session. Keep up the good questions and engagement level. We have 4 new speakers, and believe it or not, we're going to try to top the previous 4 speakers. And also, I'm glad to say that this session will also contain some of the Indian speakers that we have invited here, so we're very glad to hear more about the Indian side of things as well. But our first speaker is homegrown from Bergen, Bernt Skeie, who is the CEO of Alma Clean Power, but also the chairman of Greenstat. He's an experienced chief executive who has worked for a long time in the renewable energy and clean tech and finance and R&D side of things. He has also been CFO and CEO for listed companies on the Oslo Stock Exchange, and now he has recently launched a new group of companies, Clara Venture Labs and the like, and Alma Clean Power. So he's going to speak about achieving zero-emission shipping. So please, Bernt.
Thank you. Yes, Alma Clean Power is a company set up very recently, but it's based on actually 30 years of high-temperature fuel cell development in Prototech. Actually, we worked a lot with space, so it's been taking technology from space to the ocean space, basically. And we have huge ambitions to decarbonize the ocean space, because there are many problems to solve, but of course, deep-sea shipping, we've heard a lot about the ferries and passenger vessels, short sea, but for deep sea, we can't see any viable solution to go green, completely crossing the Atlantic or the Pacific. And there are some, well, the ambitions of the IMO are huge, so something needs to be done. And this is where we find that our technology, we know a lot about PEM fuel cells, but over the years, our focus on high-temperature fuel cells have positioned us to move on and to do something about this. And our solution is basically, this is a first generation 1 megawatt soft module. It's going to be delivered into a project in 23, 24. But you can see that it's all about efficiency. the high temperature fuel cells adds to 60 plus electrical efficiency. And also running at 800 degrees, the heat, if you can use that, is really adds to this and brings them above 80%. And of course also the fuel flexibility. I'll come back to that, but everybody's talking about hydrogen, but many people are also talking about ammonia. And the fact that you can run this on LNG, methanol, and also include carbon capture, because the technology, it's a closed system, it's very concentrated CO2, so it's easier, cheaper to capture the CO2. So once the infrastructure is in place to store this safe, or to use it even better, of course this technology is ready for that as well. So it's possible to go zero emission on fossil fuels. And also from space we learn a lot about building this, keeping it compact. This is not compact, this has a lot of stuff with it. So the next generation is 2 megawatts in the same size of the container. And we are rapidly setting up our organization now to do so. Last year, after Aker, the Aker group came in, we set this up, we launched the Clara Venture Labs as an innovation company. And Alma Clean Power was one of the first ventures to be spun off. We were 2 people, and now we are 30 people, and next year we'll be 60 people. So we are kind of moving fast. So speed and scale, I think that's what it's all about. You can see we started in 91, and in 2010 we had the first passenger vessel running on hydrogen in the harbour of Bergen. Some of the partners are listed here, and some are alliances. 24, as I said, the demonstration, the 2 megawatt solution on ammonia, will probably be the first in the world of that size running on ammonia. And in 25, we will have the commercial product ready, and the production facility will start. So it's the second half of this decade is really when it's going to boom. The demand side is there, so it's all about supply. And this is also some of the reasoning why we believe that solid oxide fuel cells in this case will play an important part. This is the 2050 forecast from DNV saying 40% of the fuel mix in 2050 will still be LNG. And of course ammonia then being the second largest one, 25%. So technology, well, what we tell ship owners is you shouldn't choose the fuel, you should choose the engine. And having an engine that's fuel flexible is, of course, better. And I think most people see that now, and we have a lot of interest. This is also an example of where we compare it actually to PEM fuel cells and dual fuel, combustion engines. And this is the efficiency itself is the big thing. It reduces, of course, the use of valuable gas, and also with the CO2 tax coming up now, you actually get as much, and in that end, you get reduction in CO2 tax is also something that really makes this an interesting technology. We can't go through all of these details in 8 minutes, but this is the most famous, I guess, or known project that we're working on. This is where we're going to do 2 megawatts with the 1 megawatt containers. It's a retrofit of a Viking Energy. Eidesvik Group, where also Equinor and Wärtsilä and Yara are part of this, together with Maritime Cleantech and a few other partners. The testing will be done at Sustainable Energy Catapult, south of Bergen. You should actually visit. And it will be running from 2024. But we also see that this concept of, Hystar was talking about it, we are also focusing very much on the modular concept where we can build this in an established balance of plant. In this case, to the left you can see Skarv is an FPSO run by Aker BP now. So we have an intention to put a fuel cell on board this FPSO. It actually releases 340,000 tons a year, which is quite, it's a part of the Norwegian total emissions. Actually, the ocean space, it's roughly 1/3 of the emissions from Norway is from the Norwegian continental shelf, transport, shipping, and oil and gas. But what we do here is that we replace the two 30 megawatts LM 6000 turbines, 60 megawatts with 30 2 megawatts soft modules. And in this case, you will cut more or less the emissions in two, and you reduce the fuel use. So this is quite a good business case already today. So to sum up, it's all about high temperature fuel cells, zero emissions for deep sea shipping, and we are very much now focusing on the maritime. The IMO have been pushing the standards much more than oil and gas side, but what's happened now during the war and the energy crisis in Europe, of course, also replacing gas turbines offshore on rigs, and also and land-based systems are very much in talk. So we are very much involved in seeing what this technology can do also in other areas. So that's it. Thank you.
Thank you very much, Bernd. Our next speaker is from India. Mr. Siddharth Mayur is an entrepreneur with over 23 years of experience in international ventures in clean energy, real estate, and agriculture. Maybe you want to install that while I speak. He has been the entrepreneur behind the company H2E, also a spin-off called Homey Hydrogen, and you'll explain the relation, I would assume. And it's a company that strives to innovate and develop reliable and affordable solutions for a range of applications for distributed generation, including green hydrogen, alternate e-fuels, and power solutions. So Siddharth, please.
Thank you. Thank you, everyone, and thank you for the warm welcome here in Bergen. The weather, I think, also has been playing well for all of us. And being the first time visiting Bergen, I must say that it's been a delight right from the time I was landing, and I was actually messaging my family that I'm landing into heaven actually. So you guys got a beautiful place here. So I'm going to keep my presentation a little more on the political side than the technology side. I think we've heard a lot of technology. Take a different approach here. As we all know, energy is life. I don't need to go further into it. But I'll get into an India perspective and where India comes from, or what we suffer right now. We suffer the typical climate catastrophe. Almost 60% of India does not have more than 8 hours of electricity. But at the same time, we have to take care of the planet. We cannot burn more coal, but we cannot let the country or the people suffer either. So you have to progress as a country. So there's a big climate dilemma, and which is leading to the climate catastrophe, as we call it. But the silver lining is that technologies like hydrogen technologies on the battery side, fuel cells, are becoming more and more affordable. And Sir just asked about 1 kg of hydrogen. Even that is not affordable for cement. And I'll take it up later, but I think it is affordable even at $3. So there are different technologies that are in play, and that's where I think this whole partnership, Indo-Norwegian partnership, comes into play. I'm going to just talk about a different subject altogether. Nobody talks about the farmer. We all eat food, and it's because the farmer is toiling in the farm. India, for instance, is an agrarian economy. We've got almost 118 million cultivators who are farmers, who own land holdings less than 2 hectares. And that's the big opportunity for energy in India. And these people live in abject energy poverty today, which drives them to losses, drives them to suicides, and the misery that the farming community experiences. So it's the energy poverty that is what I was talking about. Now, how do we save the planet? And India is going to take a big lead because we are going to be one of the biggest consumers, be it for electrolyzers, be it for fuel cells, be it for energy, or anything that you can think of. We are the biggest consumers in the world. I would not look at China because I really don't have right numbers on China, but India definitely we are. So the first thing we have to do on technologies, and which is the topic for my talk today, is to conserve. How can we conserve energy? 1 euro saved is 2 euros earned, is what my grandfather told me when I was a kid. So you save 1 kWh, you actually make 2 kWh. And in India, the transmission distribution losses are almost 20 to 22%, in some cases almost 30%. So how do you reduce the T&D losses? How do you go more and more distributed in terms of energy generation, whether it is gas, whether it is hydrogen, whether it is electricity? So conserve and then you converge. You converge various technologies. So is a fuel cell an answer to fossils or ICE engine? Is hydrogen an answer to gasoline? Is battery an answer to conventional fuels? No, it is convergence of all of these technologies coming together. That solution is what beats gasoline, and it can even beat gasoline today if all of these technologies converge into one. And then you collaborate, and that's what brings us here. We are in a hub where a lot of technology happens, and I come from a place where a lot of technology gets implemented. You mass scale it. And that's how we become more and more climate responsible. And I'm coming to a concept that H2E as a company is working on, is to build a climate change vaccine. So, there were 6.2 million deaths due to COVID-19, and we all went berserk. I think we went in a lockdown worldwide. How about 5 million per year people dying just because of climate change? I don't think we've even kept our houses shut for a single day. So that brings to the concept of developing a climate change vaccine. And all of us sitting here in this room, whether it is companies like Static, who nurture startups, or technology companies, investors, funding agencies, all of these are the ingredients that go together to build a climate change vaccine. And this deserves for the entire world to come together, just like we came together for COVID. And these are the ingredients of the net zero or the climate change vaccine. I call it Climate Shield. So it is renewable energy as a technology, and that is increasing and getting better and better. How can I get solar energy or wind energy as cheap as 5 cents or 6 cents? Then the hydrogen becomes cheaper and cheaper. You talk about water. Not all of us mention water, but it takes 10 liters of water to produce 1 kg of hydrogen. And in India, where we don't even have water to drink, you're talking of a political situation which can completely derail the entire hydrogen story. Turtle up. I mean, it won't take more than one election for hydrogen to really go to hell as far as India is concerned. So water is something we really have to work on. How can you get wastewater treated it into things, or how can you reduce the SCM of water or the purity of water that the electrolyzer requires? That's where a lot of technology work, or that's the technology challenge that we need to take as innovators. Then is the electrolyzer, of course, we all know about that. Then you're getting into distributed power generation, the microgrids, using fuel cells, solar, battery, hybrid solutions. Then the H2 infrastructure, and then mobility. So then you address one sector at a time. You get into the farming sector, you get into oil and gas, mobility, residential. So these ingredients or these technology alternatives can help solve problems in each of the circles that we live in. So, you live in the food value chain, you live in the security value chain, industry value chain. So that's an example of how we look at the value chain developing in India on a distributed scale, where you have the renewables working with electrolyzers and hydrogen, the storage technologies, and then addressing the distributed scale of use for these technologies. Going back to about the company, or where I come from, H2E, that's the company that I helped form in 2009. So we've been talking hydrogen for 13 years already now. And we have a few spin-off companies. One of them is Homi Hydrogen, which is focused on making electrolyzers. And H2E makes fuel cells. And what is our USP is that we would make the most ethical, the most cost-effective, and the most sustainable electrolyzers or fuel cells on the planet. I'm making a very audacious claim, but that's what the focus of the company is. And we're working steadfast on that. We have partners in Norway. Greenstat is one of the partners in Homi Hydrogen. And we also have an Italian company who's bringing in technology. They're equity partners. So we've really put this entire global collaborative effort in practice. So we're not just talking about it. We are not just signing some documents or MOUs or NDAs. We're actually putting things on the ground. And by end of next year, we should already have a 100 megawatt facility up and running in India with the infrastructure for a giga scale facility on electrolyzers. And then focusing more on the stack, we are looking at distributed production of electrolyzers. So we're looking at 4 satellite places where we will manufacture the electrolyzers, doing something innovative in terms of how you manufacture things. So you keep the Intel inside, you keep the stack at one place, and you build the laptop at multiple locations. That's how we're trying to treat the electrolyzer segment. That's about our company, where we are moving. We are working on all the 4 types of electrolyzer technologies, and we're working on the high end of the technology curve, but the low end on the cost curve. Where we focus on is electrolysis. We also focus on alternate fuels. I think Bernd mentioned about ammonia. We are also working on SAF, methanol, so co-electrolysis using carbon dioxide with the solid oxide technology, or hybridizing that with the AEM or a PEM. So we're working on these various combinations to bring a reasonable solution. And again, the way I look at it, or the way we look at it as a company, you never go and ask a refinery that which refinery technology you're using. You only ask them what gasoline you're producing, what is coming out. So right now, electrolyzer is flavor of the month, but 4 years down the road, I don't think anybody will ask electrolyzer. They'll ask, what is the cost of hydrogen? What is the alternate fuels you can generate? That's where the core focus is moving towards. And then on the fuel cell side, we are looking at a small combined heat power systems going into individual homes. I have close to 800 installations in German homes. Right now, we're exploring Europe for the CHP market. Also moving into bigger systems, we are looking at shipping. That's a big opportunity that was mentioned by Bernd in his address. So we're looking at providing the technology backbone to the shipping industry as well. And this, I think, that defines a lot of things for us. Was a very important day in our lives. I think after my birthday, the day I was married and my children were born, this was the 5th most important day for me, when we commissioned India's first green hydrogen plant in a place called Assam in the northeastern state of India, the most difficult terrain that you can ever imagine to work. But we chose that place, and we've delivered it. We are producing 30 kg hydrogen per day since 20th of April. And that's why I've borrowed from Neil Armstrong's line that it's a small step for mankind, but a giant leap for climate change. And last but not the least, I think the most important topic of my presentation is these last 2 slides. What is written is in Sanskrit. It says Swadeshi Urja for Swavalambi Bharat, which means unless you can produce energy independently, you cannot become a self-reliant nation. And that goes for every country on the face of earth. Till you're importing, till your import bill is high, you cannot be self-reliant. And India imports 190 billion worth of energy. So we have a lot of work to do. And what we are focusing on is creating Urja Udyamis. It's again a Sanskrit word. Urja is energy. Udyami is an entrepreneur. So we are collaborating with companies or institutes in Europe. And this is where I see a big opportunity to collaborate with Norwegian companies as well. To build a complete courseware where we train people who can then go and implement these. We need implementers, we need installers who can actually do installation in a very ethical manner without cutting corners, so that the technology does not get a bad name and the user gets the maximum benefit. The idea is to create at least 100,000 of these energy entrepreneurs by 2032, and that's the mission that we have taken as a company. These 100,000 will be able to then go to about 358,000 villages in India, and by 2040, these 100,000 will be responsible for at least 300 million people to become net zero. So that's the approach that we are taking. Unless you have people on the ground who can take your electrolyzer, who can take your fuel cell, we are all just going to be here and we're going to make beautiful discussions, have good applauses, but we are not going anywhere on technology. You need people on the ground to implement this. So that's an initiative, an important initiative that we take. And at the end of the day, it is, that's where I belong to. I belong to a farming family. That's a humble Indian farmer. And I think he deserves the work that we're doing. So thank you very much. Ready to take any questions you have. Namaste.
Thank you very much, Siddharth, for a thoughtful and great introduction and bringing us down to earth, literally. It's interesting, talking about scaling. Actually, India is, by definition, the most scaled-up nation with the biggest population in the world, 1.4 billion. And just the number of you mentioned the number of 180 million farmers. I would guess that in Norway we're about 100,000 farmers today, the same number as you mentioned that you need for the energy entrepreneurs. So scale is a factor here, and also thank you for bringing up the fact that we have to think about the different needs of different peoples, markets, conditions, and not just thinking about the best technology, but also the most useful technology. So thanks for that. All right, we have also a speaker with us who is not here, but he should be here digitally. So we have Mr. or Dr. Rajib Kumar Mishra, who's the chairman of PTC India. And while technology is at the core of the energy transition, it is imperative to understand the market dynamics in order to succeed in scaling, like we just talked about. PTC India is a leading solutions provider in the energy value chain, and Dr. Mishra is joining us digitally. And for all of you wanting to learn more about the key drivers for adoption of green hydrogen in India and what it means to develop an enabling business environment for adoption of green hydrogen, I recommend you to listen carefully to his speech, which starts now. So if you hear me now, Dr. Mishra, the floor is yours.
Good evening. Hello, everybody. And it is my privilege to address it from my office. I wanted to come to Bergen. How I am connected to Norway is something which I would like to share with the audience before I start my conversation. Way back 24 years, I was in Trondheim at TNU as a student for my post-graduation program. And I'm connected there. I stayed there in Trondheim and I visited all your cities and all the fjords in the country. And I enjoyed my stay there. Let me begin with that. And when I'm addressing this gathering, I recall all the good time of what I have spent in Norway. The most important thing, what we are trying to find out today in Indian context is how big this market is and where we are. We are hoping that something great will happen. And I would like to share my presentation from this side. Will that be a possibility or?
Yes. We are waiting for the technician to, but we can now see your image on the screen, so, and also your presentation.
Can you see the presentation, please?
Not now, but we did see it just a moment ago. It was shared just a moment ago, but then now we only see your image.
Okay, to avoid the loss of time, I think I request
now we can see it. We can see it now.
You can see it? That's great.
Yeah.
So to make it straight away, I would be discussing something on the enabling business environment in the Indian context. And particularly for adoption of green hydrogen. How big is this market and what are the initiatives which Government of India has taken and where the business currently is? That is how I'm going to present it. What we can see right now is there are all forms of hydrogen, including mixed hydrogen. The requirement will be more than 110 metric ton per year, which will have all the requirements coming from refinery, ammonia, other pure uses, methanol, and other uses. And then choosing it for different utility in the country, that is transport, heat, electricity, or chemistry. We have identified how much will be the total requirement is. It is something which is coming with big numbers, and those numbers based on what we are choosing a target market, we can say that India can have a market of around 8 billion US dollars by 2030 and 340 billion US dollar by 2050. Before I go into the details of this possibility, let me tell you, the current market size is the 400 plus gigawatt of installed capacity in the country, which also includes almost 100 gigawatt of renewable, which is targeted for another 450 gigawatt in 7 years. And that's where we understand the renewable energy which will be added in future is going to be used for the hydrogen also. So therefore, I can easily say that the curve which is the load curve in the country, what we are seeing that is there is a morning peak and then again an evening peak. With the induction of or the introduction of renewable energy, there will be surplus capacity during the morning peak hours or during the day, and that can be the source for the electrolyzing and the energy requirement for converting the hydrogen. Of course, this hydrogen economy is something which all the other speakers have discussed. Upstream, the clean hydrogen supply, and the downstream. All these three things we have discussed in the past, so I'm just skipping it. The key drivers for adoption of green hydrogen, of course, India will always be known for something where we are price sensitive. We are looking for, as a developing economy, we always look for something which is affordable at the same time which is good. So cost of generation of hydrogen, green hydrogen will of course, depending upon the green electricity cost, that means the cost of renewable generation, and the electrolyzer cost will be something which will be for the capex, and then the cost of storage and transportation also will be something which will be a key driver. The cost of substituting the grey or the black hydrogen, which is already being used by many of the industries like fertilizer refineries, that also will be something which can play a very important role. Last but not the least, that is the legislative policy, creating demand through policy and direction, and pricing extended ranges like carbon. It will be a very important key driver in adopting the green hydrogen. Let me tell you that the government of India at this point of time is very keen that India can emerge as the hydrogen hub for the entire world. We are not talking only for the country, we are discussing that how India can emerge as the hub for the entire world. Now, why I am saying this? The Prime Minister has announced just on the 75th Independence Day that the National Hydrogen Mission is on the cards. We are waiting for the mission statements, committed offtake, and the directed demand. But yes, he has already announced it. Two policy which has come, one from the Ministry of Power, that is the Green Hydrogen Policy, was issued in the month of February, and subsequent to that, the Niti Aayog has, which is the main planning body of the country, they have come out with the forecasted planning institution on 29th of June, which has given us a direction on the opportunities for deep decarbonization in India. The important thing is the policy support which is currently existing in the country is the several incentives to attract investors. That is granting distribution licenses which can procure supply renewable at the concessional rate, waiving of the interstate transmission charges for entire 25 years. That means if you are into hydrogen, the entire 25 years of transmission charges will be free of cost. Allotting land in the renewable energy parks to manufacture green hydrogen. So these are the major, you can say sweetener or the attractive incentive which has been offered to the investors. The government is trying to facilitate to do ease of business through a single window, and it is also encouraging export of green hydrogen from the hub which I just mentioned. Now, where we stand as far as the cost of the green hydrogen, its ambition to produce 5 million metric ton of green hydrogen required almost 115 gigawatt of renewable energy, and for producing this, the cost of green electricity should be competitive. First of all, the cost of hydrogen through electrolyzing needs support. That means the technology support has to be there. Then the direct demand, that is 10% through the green hydrogen, which is being contemplated at the government level. The viability gap funding, that is carbon market and hydrogen credits, also is being contemplated, and the green hydrogen policy which was initially, Ministry of Power has issued in the month of February, need to have further clarifications, and that is going to make a key change. Then issues to work on is the production cost, storage, water requirements, supply chain management, and the policy mandates. So there are different task forces working on these, and many large companies, including Power Trading Corporation of India, PTC India Limited, we have a task force which is working continuously on this, so that PTC can not only emerge as the largest trading company in the country, we would like to be the largest aggregator of the hydrogen in the country. So our role as the largest trading company in the country, promoted by 4 of the largest government-owned companies, we would like to aggregate demand for consumption of green hydrogen, aggregating renewable energy supply for electrolysis projects. We can also provide with our partners advisory services through our international technology partners, and most important, whenever something new is being emerging, policy advocacy at the appropriate forums, we can provide to all our partners throughout the world. So there we are. Thank you very much for providing me this opportunity, and I hope I can come back to Norway once again to spend some time with my old friends and some of my partners. Thank you very much.
Thank you very much, Dr. Mishra, for that good presentation. We had some technical problems, but I think your message came through loud and clear anyway. So thank you very much. Our last speaker for this session is one you already heard from a little bit earlier, Mr. Alberto Litta Modigliani, who's the Vice President Hydrogen at the company of NextChem. You talked a little bit about the company and its role earlier, and from what I gathered, you work mainly within energy-intensive and chemical technology and industries, thus representing also the end-user perspective and the kind of system integration side of things. So I challenge you to just take it on på sparket, as we say in Norway, which means kind of on the fly, to have a comment on what you have heard, and also maybe some thoughts on you know, the Indo-Norwegian kind of cooperation side of things, and being such different countries and environments. What do you think about the opportunities for scaling? Yes. Hard question, but I'll give it to you.
Thank you, Daniel. Yeah, and yeah, there's the advantage to come to be the last is that I can take inspirations from the good interventions of the other colleagues. So I would like to go through three main points, I would say, yeah, and then I will elaborate around that. The first one is the key word is scale up. Yeah. Second one is the value chain, and the third one is integration. All right. So scale up, it's something that we talk about a lot in the hydrogen business since a few years already. Yeah. It looks like if you do not have a gigawatt scale project, you do not count anything in the business. Vice versa, we have to look at that in perspective, under different perspectives. The question is not about the largest possible scale. The question is about the right scale. Yeah, it seems obvious, but I'm coming from the process industry. I just give you an example to give you the concrete difference between two different industry sectors. When you talk about large scale, normal scale in ammonia industry, it's about 3,000, 2,000, 1.5 thousand metric tons per day of production, which means, in terms of electrolysis capacity, gigawatt scale, right? So it's beyond today the industry capacities, the industry capabilities, also, although we all talk about that. But if you talk about small scale ammonia, between 50 to 400 metric tons per day, it's very small, it's tiny small for the ammonia industry, but it's already between 50 to 200 megawatt capacity in terms of electrolysis. So it's industrially viable, it's more or less ready, and it's already high enough in terms of capacity for being significant for the hydrogen industry. So we have to put this into perspective. Yeah? First point. The second is that scaling up is not only about megawatts and gigawatts. It's about scaling up engineering capabilities. It's about, of course, scaling up manufacturing capacities. And it's about also scaling up the flexibility of the solutions that we put in place. I just give you some examples. Being on the EPC side, very often, when we ask offers to the electrolysis manufacturers, for example, for already medium-scale solutions, the question very often is, this is what we have, you take it, or you leave it. So then we start discussing about interfaces. We start discussing about making the supply chain and the design suitable to the country where we want to realize the project and suitable for the solution. Because maybe we have an industrial process downstream which has its own features, for which the electrolysis operation must be fit to. And then the answer very often is that we are too busy. We are so busy that we do not have engineers enough to follow your requests. And that's an obstacle that we all have to overcome. It will come with time, yeah? But it is there today. Also together with the fact that we are so much taken by the gigawatt scale dream that very often when you ask for something around 10 megawatts, you have no answers from the industry. And then the other question, I move to the second point, is maybe focusing on electrolysis only can be misleading. Electrolysis is so much under the spotlight of the entire industry that certainly will come. We see a lot of positive things. Yeah? NEL moving on, manufacturing capacities being realized and increasing and scaling up, etc., etc. But then we very often forget about the criticalities of storage, about the criticalities of hydrogen compression. If you ask around to many experts around the industry, they will tell you everything about the electrolysis industry trends and features for the next 10 years. But if you ask about compression, it's more of a question mark. And it is something that it is very often neglected. There is certainly not enough capacity, not enough performance in terms of purity and possible contamination of the hydrogen which is going to be compressed, etc., etc. So it is something that has to be taken care of, and that we, as EPC contractors, we see. Yeah? We see because when we have to combine all the technology bricks together, we suffer from what is available on the market. And then there is one point which I've seen also in Stefan's presentation. It's about modeling and integrating the performance of the entire stuff. This is also something that is extremely critical for not only EPC contractors, which are eventually the ones who are carrying the performance guarantees, all right? But also the individual technology suppliers. And actually, if you look at this, I mean, if you compare with a more mature industry, like power or like petrochemicals, etc., we do not have the luxury in green hydrogen to turn back and look at the last 40 years of performance. We do not have this luxury. So what the best that we can do is to set up performance models, something which reasonably reproduces the future and expected operation of the plant. And then if you have to go to banks, to lenders, or to your higher management for receiving the approval on a final investment decision, this is the best that you can bring. So this is something that all together as an industry we have to work on, because putting together something which is reliable as a modeling tool, simulating the performances, needs a lot of inputs and a lot of information from all the different technology suppliers. So when I was speaking this morning and telling that sharing IPs, it is also something which is critical, it's also about this. Because if you want to put together a performance model, then you have to open the box and look into it and see how it works. So these are the the three major things I wanted to share. Of course, open for questions.
Thank you, and maybe an applause first. Maybe I can, we have just a few minutes because we should have a 20-minute break before 4:30. But please, if you could invite both Siddharth and Bernd up on the stage. And thank you very much for, that was exactly, by the way, what I was thinking of. So thank you for responding so perfectly. It's late, it's a beautiful day in Bergen, it's not raining, so we should probably go outside and have some air, but do we have any questions from the audience that could, any comments or questions from these three or actually four speeches that we heard just now? Or should I start myself? Knut from, yeah.
Just a short question to...
Well, please grab a microphone, because otherwise the people following the stream cannot hear you.
Of course. Yes, hello. May I direct a question to you, Mr. Bernd Scheie? On the topic of the international focus on challenges that are combated from two sides here. When it comes to bottlenecks, do you have any experience from what was commented on this last presentation?
Bottlenecks for scaling, you mean? Or?
Yes, and technological, from technological point of view, and integration of different technologies.
It's always interesting to discuss the many sides of developing new technology, of course, and the robustness of the solid oxide fuel cell itself is one thing, and then, as you mentioned here, the robustness of the value chain, cooperating, bringing together people with the same ambitions. That's why we are working with some very key players, and we're not looking for giga or scale factories just to do that. We need to be relevant in a sense, so we need to plan for the scale, and that means integrating the systems, the organizations, and the drive, I guess, the ambitions of all partners. You can't do this alone. You need to work together with people, best people around the world to make this happen, and that's really what we are aiming for now. Also, of course, the bottlenecks, the normal bottlenecks to deliver new technology to the world is capital, and then you have, of course, capacity. And that's why we brought in the ARCA group, because that increases that part of it. Competencies, and also then collaboration. And the collaboration aspect, of course, is all the way through the value chain, also crossing country borders and, bringing together the best forces around this. So, Siddharth, you want to comment?
I think the biggest bottleneck, I'll just pick one component, maybe it's a membrane or electrolyte, but if you get into the value chain, there are a lot of these small components nobody talks about. We all talk about the electrolyzer, that's the glamorous story and it catches headlines, but the blower, the pump, the electrolyte, the powder, the paste, the membrane, and a lot of these components, surprisingly, has less than 3 suppliers in the world. And if you're looking at giga scale, if you're looking at the numbers that we're talking, these guys may just not have the capacity. So developing these vendors is going to be the biggest challenge. Unlocking the IP so that somebody can build a good mass flow controller, for instance, somebody can do a good membrane development, or somebody can do a good powder chemistry. So these will really bring down the cost, number one, and it will make this sustainable, because just bringing down the cost is not important. You see, we have to last beyond the honeymoon period. We have to last, the marriage has to be a longer one. So I'm really looking at 2030, 2040, 2050. And if you're not able to do that, then we all fall down together.
If I can add one thing, it's interesting what you're saying, yeah, because you enter really into the details of things. And it's not only about equipment, but it's also about skills and labor force. Imagine we have a pilot plant with, in Europe, which is suffering 6 months of delay because we do not find welders for making hydrogen-safe weldings.
I'll give them from
The-
India next 5 years.
Yeah, but they must be certified, etc., etc. So sometimes you suffer delays. Yeah. So there is a whole of a set of competencies and operators, etc., which must be built in every single country.
All right, we're nearing the end. Just as we were having this session, there came in a news bit on my phone that said an aluminum plant in Norway was closing down because of electricity prices. And we are really at a quite extreme point of time. But how do you think, I mean, we're talking about all opportunities, the great growth of this emerging industry, while we at the same time are experiencing the kind of roughest periods of spikes in gas prices, electricity prices, at least here in Europe. How do you think this will affect this industry in the long term? What's happening now? Anyone has a good, what do you call that, crystal ball?
Crystal ball,
Yeah.
I would love that. No, I think from our end, the grid system in Norway, we also have this electrification of the continental shelf with the gas turbines actually running on green hydropower, which is something that's been discussed a lot lately. So it's very much on the political agenda, and that makes our technology, these 2 megawatt modules, very relevant in the case that you can start building a small scale and you can build on this, and actually instead of setting up new network, the grid, which takes years. In Norway, it takes 10 to 14 years just to regulate it before you start building it. So we have discussed this at very high government levels to actually set up a 320 megawatt system outside of Bergen to actually provide energy for green technologies coming out, like the carbon capture system, the Northern Lights, and also we have blue hydrogen production out there. They all need electricity, and it's not available to them today, at least not at these prices. So with a high efficiency fuel cell system or a power unit, that would actually be very much of interest to the country as such. So for us, it's an opportunity. At the same time, it's scary for everybody around us, I guess. Europe, do you want to this end?
Another massage on the crystal ball,
yes.
Right? Yeah. I don't know, it's a very difficult question, of course. And I think that there is an opportunity here for rethinking the large-scale decentralized projects relying on self-produced power. At a certain moment, until a few months ago, the questions of flexibility and all the questions related to the long lead time needed for building hundreds of megawatts of solar or wind in Europe for permitting purposes, etc., we came to the conclusion that, yeah, maybe getting connected to the grid was the right option. But then eventually, yeah, overnight, that was an option, not an option anymore, right? So maybe, and also to come to your first question, Daniel, bilateral agreement between countries putting together demands and availability of land and renewable sources can maybe come to the agenda again, and maybe powering Europe from Northern Africa or powering certain other parts of the world from India can become a viable option, at least for the very large scale projects.
Thank you. Siddharth, do you want to have the last word on that crystal ball? I think that's the last one.
Well, I think I have a lot of demands from the crystal ball rather than the answers for them. But I think I agree with what both my fellow panelists have said about this. And we face the same dilemma in India as well. So when you were talking about the aluminum plant shutting down, and we're talking, so it's a lot happening in India and that part of the continent. And I think this is again a part of the whole transition process or disruption, as you call it. And if you look at where we all belong today, we are at the most important time in the history of at least our few generations. Because if you look at energy transition, This is the 5th transition since mankind came into existence, from Stone Age to wood, coal, gasoline, hydrogen. So imagine how lucky we are. We are witnessing a complete shift that has happened only 4 times before in whatever million years of civilization. So a lot of things are going to close down, a lot of things will open up, but yeah, it's a great opportunity.
I think those were the famous last words. So the long historical lines here are being drawn. So thank you all very much for great contributions to the session. And we have now 15 minutes break. Please take some air and join us in the last session in the plenary. So thank you.
Thank you.